Hello everyone, it's a pleasure meeting you all in my mathematics class. I'm continuing with my Convergence and Divergence series discussion. I've done a lot of problems and I will be doing problems in Convergence and Divergence of series, and the students will definitely benefit watching my videos, and keep watching the videos so that you will benefit a lot. Today I have taken yet another problem. Test the convergence of the series 1 plus 2 to the power of, actually this is 2 to the power of 1 divided by factorial 2 into x plus 3 squared divided by factorial 3 into x squared plus dot dot dot. It goes on like that. Now you see that I take this. See, if in all these problems what we do is we find the nth term and test on the nth term whether the series is convergent or divergent. And we have got certain tests. Depending on the problem, we apply the test. For d-elements test is there, Cauchy ratio test is there, and you have got logarithmic tests on there. So you see, apply the different tests and find out whether the given series is a convergent or a divergent one. But for all problems, what is most required is finding the nth term. So once that nth term, that is an, here you see that a1, a2, a3 up to it goes on, an plus 1 like that it goes on. And it is an infinite series. It may start from 0 or giving n is equal to 0, n is equal to 1, n is equal to 2, like that it may go on. So you see that we find the nth term and work out on the nth term and find out whether the given series is a convergent or a divergent one. Here in this problem what we do is, I find the nth term. You can just see that I have written the nth term. Nth term will be somewhere here. Say let us any term, I will call it as it is here, your an. And this an is nothing but you write the term in such a way that this, when you apply n is equal to 0, you will get the first term, n is equal to 1 the second term, n is equal to 3 the third term, n is equal to 4 the fourth, like that you can get. So you see that here I have written n plus 1 to the power of n. Here you can see this n plus 1 to the power of n. Here it is 1, 2, 3, like that it goes on. And so this is n plus 1 to the power of n divided by n plus 1 factorial into x to the power of n. Now when you give n is equal to 0, what will happen is, this is n is 0, 1 to the power of n is n. This is 1 factorial. You are getting this, see? 1 to the power of n. Here you are getting 1 to the power of n divided by factorial 1 into x to the power of 0. So you see that when you give n is equal to 1, n is equal to 0, you get the first term. This is 0, 1 to the power of n is anything raised to power 1 is n is equal to 1. 1 to the power of 1 is 1. This is 0, 1 factorial, and x to the power of 0 is 1. And the second term, give n is equal to 1. 1 plus 1 is 2. 2 to the power of 1 divided by factorial 2 into x to the power of 1. Give x is equal to 2. 2 plus 1 is 3. 3 square divided by 2 plus 1, 3 factorial. So you see that like that it's 0, 1, 2, 3, like that. It goes on up to, and here I go to the end. I take this nth term. Now, I take this nth term and then perform the D'Alembert's root test. What is it? D'Alembert's root test. What does that D'Alembert's root test say? It tells you that you find an plus 1 divided by an and take n to tend to infinity. And if it approaches a finite limit L, see, here I have written here, say call it as L. Let me call this as your L. This L. And if this L is less than 1, see, if this L is less than 1, if L is less than 1, convergent, L is greater than 1, divergent, L1 means fails. The test fails. What is that? So what is D'Alembert's test? You find an plus 1 divided by an and allow this n to tend to infinity so that you will get a value L. See whether that L is a finite, is less than 1 or greater than 1. If it is less than 1, convergent. If it is greater than 1, divergent. And all if it is equal to 1, the test fails. This is D'Alembert's test. So I am going to apply the D'Alembert's test here to find out whether this is a convergent or a divergent series. For that I have written this an. An is n plus 1 to the power of n divided by n plus 1 factorial into x to the power of n. And this n takes the value 0, 1, 2, 3 are there. So you give 0, you will get the first term. You will get 1. 1 means this, 2 means this, 3 means it. So like that you can go to the n plus 1. It's a general term. Now an plus 1 means wherever n comes you put it as n plus 1. So here n plus 1 means n plus 1 plus 1 is n plus 2. So this will also be your n plus 2. To the power of, here n will become n plus 1. And here x to the power of n will become n plus 1. So this is my an plus 1 is, see an plus 1 is, this is my n plus 1th term. Now what I do here is, I divide an plus 1 divided by an. And when I do the division, you see that this is n plus 2, this one n plus 2 to the power of n plus 1 divided by n plus 2 factorial into x to the power of n plus 1 multiplied by, see if you put this value, put it upside, divided by an, see, divided by an means what will happen is this, n plus 1 factorial will go to the top, n plus 1 factorial divided by n plus 1 whole to the power of n into 1 by x to the power of n. That is, the denominator will go to that, see, an plus 1 is this, an is this, so this n plus 1 will go to the top, n plus 1 factorial will go to the numerator. On simplification, what is this? N plus 1 factorial is nothing but, here you have got n plus 2, this is n plus 2 factorial, this is factorial n plus 1 into n plus 2, here you have got factorial n plus 1, so you see that this factorial n plus 1 and factorial n plus 1 will get cancelled. Here it will get cancelled. And you will be left with what? Here you can find that this is n plus 2 whole to the power of 1. This is n plus 2 whole to the power of n plus 1. So if this will go off, n plus 2 will go off, leaving you with n plus 2 whole to the power of n. Here you have got n plus 1 to the power of n into x. Because this is x to the power of n, this is x to the power of n plus 1. So you get n plus 2 to the power of n divided by n plus 1 to the power of n into x. Which I write it as, I take this n outside and here also n outside, so that n and n will get cancelled, giving you 1 plus 2 by n to the power of n divided by 1 plus 1 by n whole to the power of n multiplied by 6. This we will take it as out. So I will repeat this. See what I have done is, I have found my nth term, that is nth term, an. And I also find the n plus 1th term. And for applying the D'Alembert's test, I do the division an plus 1 divided by an, and when you put an at the bottom, your denominator will go to the top. So on simplification, we will find that n plus 2 to the power of n divided by n plus 1 to the power of n into x, because there is x to the power of n and x to the power of n plus 1 gives you x. And I rewrite this as taking this n outside, here also n outside, they will get cancelled, giving you 1 plus 2 by n whole to the power of n plus 1 by 1 power 1 plus 1 by n whole to the power of n into x. Call this as your 2. Let us have the reference as 2. Now apply D'Alembert's test. Allow this n to tend to infinity. When you allow this n to tend to infinity, here you see that when you perform this n tending to infinity, here you will find that 1 plus 1 by n whole to the power of n. Then when n tends to infinity, this is nothing but your, it is an exponential series and its value is e, incommensurable number e. See, I have written here. Whereas this one I have written here, you see that 1 plus 2 by n whole to the power of n can be written as 1 plus 1 divided by, this 2 by n can be written as n by 2 whole to the power of n by 2, you write it as n by 2 whole square, so that these 2 and 2 will go off, giving you what? No, I am not changing anything. I am rewriting as it is. That is 1 plus 2 by n whole to the power of n, which is equal to 1 plus 1 by n by 2 to the power of n by 2 into 2, because 2 and 2 will go off, giving you the same thing. I am rewriting it. Now when you allow this n to tend to infinity, n by 2 will also tend to infinity. N tends to infinity means n by 2 will also tend to infinity. N by 2 will also tend to infinity. N by 2 will also tend to infinity. So when this tends to infinity, this is nothing but e. This is also e. That is nothing but your e square. So that is why I have written it as e squared divided by e into x, which is equal to xc. This is your L. So this an plus 1 divided by an by D'Alembert's test, n tending to infinity is nothing but your L, which is namely your xe. Now L is less than 1. That means x is less than 1. If xe is less than 1, that is, if x is less than 1 by e, it is a convergent series. If xe is greater than 1, that is, x is greater than 1 by e, then it is a divergent series. This series will be convergent if x is less than 1 by e. And it is divergent series if x is greater than 1 by e. E is nothing but the inconmensurable number to whose value is 2.71828. Okay. Now, he said this is x greater than 1 by e, therefore this will be a divergent series. But if xe is equal to 1, that is, if x is equal to 1 by e, this D'Alembert's test fails. So what happens is, we have to go for some other test to find out whether this series, what will happen to the series if x is equal to 1b, whether it will diverge or invert, converge. We do not know what will happen. So we have to use some other test to find out whether this series yes will converge or diverge for x is equal to 1 by e. So you have to take care of this. So this is a very simple problem, straightforward. Only thing is how to write this. A n is very, very important. It is ranging from 0 to infinity, I have written. Okay. Now, let us try to find out what will happen to this series if x is equal to 1 by e. Okay. Now, let us continue with this. See, what I am going to do is, I am going to use what is called your logarithmic test. What is that? I am going to use my logarithmic test. This is the logarithmic test for the series when x is equal to 1 by e. That is my question. So, what does this logarithm test says? It says that given a series, you find this an and an plus 1, divide an by an plus 1, take the logarithm of that and multiply it by n and allow n to tend to infinity. What is that? Allow n to limit of n tending to infinity. So allow this n to tend to infinity by taking n into log of an by an plus 1. And if it is equal to your finite limit L, and if L is greater than 1, the given series will converge. That is, given a series, you perform an by an plus 1, take the logarithm of that, multiply it by n, allow this n to tend to infinity. If you find that it tends to a finite limit L, and if L happens to be greater than 1, this series, the series that you have taken is a convergent series. If L is less than 1, the series is a divergent. The series diverges or it is a divergent series. Okay. So this is my logarithmic test. So limit n tending to infinity of n log of an by an plus 1. If it is equal to L, then L greater than 1 means the given series is convergent. If it is less than means it is divergent. Now what is it that we have taken here? Here we have found what is my an by an plus 1. That is, we have got an plus 1 by an. I have got. Say this is from 2. This is from 2. I have got here, see, here, this is what you have. This is your 2. That is, your 2 is n plus 2 to the power of n divided by n plus 1 to the power of n into x. Say this is my 2. I am calling it as 2. I am writing this as, see, n plus 2 is now n plus 2. That is, if you put an by n plus 1, this is nothing but your 1 plus 1 by n whole to the power of of n divided by 1 plus 2. Actually speaking, your an, see it is like this. Your an by an plus 1 will be, it is n plus 1 to the power of n divided by n plus 2 to the power of n into x. This is my 2 actually. This is my 2. Here you see that I take this, so this is my 1 by x. See, this is my 1 by x. This is. But because I am taking x is equal to, I am going to take x is equal to 1 by e. So I am going to discuss the case when x is equal to 1 by e. So you see that this is, so here what I do here is, I take this n outside, I take this n outside, so that you will get 1 plus 1 by n whole to the power of n plus 1 by 2 by n whole to the power of n into 1 by x. But what is the value of x? X is equal to 1 by e. See? X is, because we are going to take x is equal to 1, we are going to test the series for x is equal to 1 by e. So if you put x is equal to 1 by e, this e will go to the top. Therefore you get 1 plus 1 by n whole to the power of n divided by 1 plus 2 by n, 2 divided by n, 1 plus 2 divided by n whole to the power of n into e. Now let us take this log on both sides. When you take log on both sides, this is n. Actually you can rewrite this as, say this is like this. So this will be equal to 1 plus 1 by n, 1 plus 2 by n whole to the power of n into, so this. So what happens is that this is n into log of a by b. Log of a by b is log 1 plus 1 by n minus log of 1 plus 2 by n, and this is log a b is log a plus log b. See, log a plus log b. But here you have got log a by b form, therefore write it as log a minus log b. This is logarithmic series. So you see that logarithmic series is like this. Log of 1 plus x is equal to x minus half of x plus 1 by 3 of x squared, like that it goes on. So this is the logarithmic series. So this is the expansion of log of 1 plus x. So I use this log of 1 plus, here in the place of x I have got 1 by n. Therefore 1 by n minus half into, see, x. See here you got. So here you have got it as, see, 1 by n. Here you have got x minus 1 by 2 of x squared. X minus 1 by 2 of x squared plus 1 by 3 of x cubed minus 1 by 4 of x to the power of 4. Like that it goes on. So you see that when you apply it here, it is 1 by n, see, 1 by n minus half of 1 by n squared plus 1 by 3 of 1 by n cube dot this goes. Minus, this is 2 by n minus half of, this 2 by n whole squared is 4 by n squared plus 1 by 3 of cube of this is 8 by n cube dot it goes on like that plus 1. Now you take this n inside, so n into n is 1, then you have got the terms minus half into 1 by n plus 1 by 3 into 1 by n squared, like that it goes on. Take this, n into n is this one, so n into this, that is minus 2, then minus into minus will be plus half 4 by n minus 1 by 3 into 8 by n squared dot plus this 1 is here. Here you see that this is 1, here you have got here 1 plus 1 2, 2 minus 2 is 0, so you are left with what? Minus half. See here you can find this minus half of 1 by n, this is plus half of 4 by n. If you do the simplification, this is nothing but 3 by, see, 3 by n into half, 3 by n into half minus, here it will be 7 by n squared into, see what I do is I add these two, see this and this, I add this, that is minus half of 1 by n plus half of 4 by n. So you see that here it is nothing but what? 4 times of this. 4 times of half of n. This is 1 time minus half of n. So this is nothing but 3 by n into half. So that is 3 by, I have taken this. See, 3 by half of 3 by n minus the rest of the terms. That is 3 by 2 of n. Now you multiply throughout by n. What is that? You multiply on the left hand side by n. Then you will get it as what? N into this, which will give you n, and n will go off giving you 3 by 2 minus 1 by 3 or 1 by n dot dot dot, like that it goes on. And take n to 10 to infinity. When you take n to 10 to infinity, you see that here 3 by 2 is not affected because there is no n. Whereas all the other terms, when you take 1 by n is equal to 0, so you see that all the other terms will become 0. So you are left with only 3 by 2. So I will repeat this. Do the simplification here. You will get it as the half into 3 by n minus 1 by 3 into 7 by n squared dot dot dot, like this. Multiply this by n and allow n to 10 to infinity. When you multiply it by n and n will go off giving you 3 by 2 minus here n will go off giving you 7 by n dot dot dot, it goes on. Allow this n to 10 to infinity. You see that except this term will not get affected. This term will not get affected because there is no n. But for all other, this will become 0, this will become 0. All other things will become 0 because you are getting n at the bottom, at the denominator, that everything will become 0, and this leaving you only with 3 by 2. That is L is equal to 3 by 2. What is this? This is nothing but your L. This is nothing but your L. That is limit n tending to infinity of n log a n by n plus 1 is equal to 3 by 2, which is equal to L. Now as per this, if L is greater than 1, it converges. If it is less than 1, diverges. But this 3 by 2 is after all a number which is greater than 1. That is, L is greater than 1, therefore greater than 1. 3 by 2 which is greater than 1. Hence, the series, now series that we have taken, yes, that series, yes, is a convergent series when x is equal to 1 by e. That is all I can see. Therefore, it implies the series 1 converges for x is equal to 1 by e. What is that series 1? Yes, we have taken, called it as yes. So that series, yes, given series, the series that we have taken, that is a convergent series for values when x is less than 1 by e and also x is equal to 1 by e, but it diverges for x is greater than 1 by e. So this is all about this problem.